My name is Alex Galt, math teacher at Edina High School. Today you're going to be extending what you did yesterday with the greatest common factor by factoring trinomials after you've factored out a greatest common factor. Okay, so if I'm factoring a polynomial, my first step will always be to factor out the GCF. Make sure that's always your first step. Look and see if you can find a GCF. So what I do when I'm looking for a GCF is I do a factor tree. 2 is kind of a boring tree because it's already prime. 10 would just be 2 times 5. And 12 would be 2 times 2 times 3. Once I've made my tree, I look for numbers that they all have in common. So they all have a 2. They don't all have x's, so my GCF is just going to be 2. And then what's left would be x squared plus 5x plus 6. Okay. After you've factored out the GCF, you look at what's left inside of the parentheses after you've done that factoring. What's left is called a quadratic. It's called a quadratic because it has an x squared term as its biggest exponent of x. X to the second is the biggest exponent of x. That's called a quadratic. It's a polynomial that has a degree of 2. Its leading term has an x squared in it. And that quadratic is something that you can factor using your algebra tiles. If you remember when we were using algebra tiles to multiply, we always wound up with an x squared in the upper left-hand corner. We wound up with 1s in the lower right, and then we had some x's off to the side, off to both sides. And so as you're building, using tiles, as you're building a rectangle out of your tiles, you want to build it so that it doesn't have any gaps, but you also want to fill that, have it use that pattern. Put your x squareds in the upper left, put your 1s in the lower rights, and then build your x's around it. I would like you to pause the video and try this with your polynomial. If not with actual tiles, then at least mentally try to arrange these tiles so that they don't leave any gaps when you build a rectangle out of them. Maybe draw a picture. This is what I got when I built that polynomial into a rectangle. Notice my x squared term is in the upper left, my 1s are down here, and my x's are along the sides. There's more than one way to arrange these 1s as a rectangle. It only works to make a 2 by 3 rectangle in order to fit the 5 x's in place. If you tried a 1 by 6 rectangle, then you would have run out of x blocks. You wouldn't have been able to finish the problem. Okay. Once you have your rectangle built, then you want to look along the sides of the rectangle and figure out what the dimensions are. Because this is an x squared block, that means that it's an x by x block. So this dimension is x, and these are 1 blocks, so this is really x plus 2. This dimension here would be x, and then 3. So if I write this polynomial in fully factored form, I would write the 2 down, so don't forget to write that 2 down, and then I'm going to have x plus 2 times x plus 3. Now that I've done all of that work, I have a fully factored polynomial. Okay, so here's a trinomial. It has 3 terms, and I want to factor it. So my job is to factor this trinomial. And so what I want to do first is look for GCF. So I'm going to think about 10x cubed as a factor tree, and 35x squared as a factored tree, and 30x as a factor tree. 10 is kind of a boring factor tree because it's just 5 times 2. Excuse me. And 35 is 5 times 7, both of which are prime. 30 is going to be 2 times 3 times 5. Then after I've got my factor tree, I want to look for common factors. I want to look for things that they all have in common. Then they all have a 5x that I can factor out. So my GCF is going to be 5x. And so then I look for what's left inside of the parentheses. So I have 2x squared and I have 7x, and then I have 6. Okay. Now I'm going to challenge you with some algebra tiles. I want you to try to build a polynomial rectangle in this space that has 2x squared blocks, 7x blocks, and 6 ones. Pause the video and give it a shot, and then when you've got that answer, return and see what happened when I tried it. Okay, so the first thing I tried was I put my 2x squared blocks up here, and I put my 6 ones here, and what I found, I built a rectangle out of them. What I found was that I was going to need 2 x's to go here, and I was going to need 2 by 3, so I was going to need 6 more x's to go here, which meant I was going to need 8 x's, but I only had 6 of them. So that didn't work. So the next thing I tried was I tried laying my rectangle, my 1 blocks out just as a rectangle, and I found that I was going to need 6 ones plus another 2, which made 8 ones, and that wasn't going to work. So then I tried it this way, and this did work. So remember, I had 5x times 2x squared plus 7x plus 6. And so I have my 7x's, I have my 2x squareds, and I have my 6 ones, and that works. Okay, from there, you want to write down your dimensions. So the dimensions here would be x by x and 2, so x2. The dimensions here would be 2x and 3. So my final factored version would be 5x times x plus 2 times 2x plus 3. So that's the process for factoring using algebra tiles. You're gonna practice this factoring. Make sure you always start with the GCF and then use your algebra tiles to make a perfect rectangle. And then once you have your rectangle, write down the dimensions to put it in factored form. I want to warn you that you might have to do some guess and check like I did of trying different rectangles to see which one would actually work for the problem. It doesn't always work out on the first try. You sometimes have to play around a little bit in order to get your rectangle to work out. The general format, though, is you want to make sure you put your x squared blocks up there in a rectangle, and you want to put your 1 blocks down here in a rectangle, and then try to fill in with x's to make it fit. Then you write down your dimensions, and that's your factored form.